Hope everyone had a good day. I'm going to start with 55 because I got that question multiple times. But then I'll also run through 47, 49, and 51, just touching on those because there were questions on those too. But 55 came up the most, so if you want to, that's all you care about. I'll show you this and move on. So the first part of 55 says to graph the function on the given interval. So if I'm just typing it in to wrap my head around it, e to the x over 4 cosine pi x over 4, and I'm going to make sure I'm in mode radians. 0 to 2 is the interval that I want to see, so window is 0 to 2. That's from yesterday's scale, so it's probably pretty off. If I look at the table, I can get a feel for what some of my y-axis are from 0 to 2 also. So I'll go -1 to 3 on my y, just so I can see the whole thing. Okay, so that's part one. Part B says to find and graph the secant line through the points on the graph. So my endpoints are 0, so for my secant line, 0 comma something and 2 comma something. If I plug in 0, e to the 0 power is 1, 2 times 1 is 2, times the cosine of 0 over 4. Cosine of 0 is 1, so that would be 2 times 1 is 2. I do have my calculator, but I can, I was thinking I could do it without, but I can't because I'm going to plug in a 2, e to the 1/2 power. I don't know the answer to that. So, but when I plug in 2, I'm going to get 2 pi over 4, which is pi over 2, and the cosine of pi over 2 is 0, so that's going to zero out the whole thing. So just to double check my table, at 0, 2, and at 2, 0. So it wants me to come up with the equation of the secant line for that. So I've got a point, and I'm going to get a slope here, y2 minus y1 over x2 minus x1. -2 over +2 is -1. So point slope, y minus 0 equals -1 x minus 2. So it's going to be y equals -1 x plus 2. So there's the equation of my secant line from start to finish. And what we learned from today, hopefully, and this should make complete sense, as long as a graph doesn't undergo any jumps or breaks of any kind, in other words, it's continuous, then whatever the average rate of change is on an interval start to finish, at some point, at least one time, if not multiple times if you got a graph going up and down, but at least one time, there should be a point on the graph where the slope is exactly the same as that average rate of change. So there has to be at least one point on this function where the slope is -1. So what we're going to do to find that is we're going to take the derivative and set it equal to -1 and find out where that's occurring. So I'm going to see this as the first times the second. So first times the derivative of the second, and the derivative of cosine is negative sign, so I'm going to throw my negative out there, of pi x over 4 times the derivative of what's inside, because that's the inside, so times pi over 4. First times derivative of the second plus second times derivative of the first, which is the derivative of e to something is e to the something. But again, times the derivative of what's inside. So times the 1/4. Whoops. Let's see that. So in cleanup, so the 2 and the 4 are going to reduce there. I'm going to get negative e to the x over 4. Oh, there's a pi over 2 out in front. Negative pi over 2. Negative pi over 2 e to the x over 4 sine of pi x over 4. Plus, and 2 and that 4 are going to cancel, so we're going to have 1/2 e to the x over 4 cosine of pi x over 4. And equals negative 1. So I'm essentially solving this equation, which is, I'm going to say impossible without a calculator, but let me make sure I'm not missing anything. If I factored out an e, I could factor out a 1/2 e to the x over 4, and I'd be left with negative pi sine of pi x over 4 plus cosine of pi x over 4. And I want where that equals negative 1. I'm going to say this is impossible to do without a calculator. So to find the location, and I'm trying to think if this is the one where I looked at the answer, and I think it's a decimal answer, so that makes sense that you probably need a calculator. So I'm just going to type, how am I going to do this? I'm going to get rid of this for a second, and I'm going to type in negative 1 as one equation, and I'm going to type in this as the other. Second e to the, oops, x over 4 times 1/2 times negative pi sine pi x over 4 plus cosine pi x over 4. Alright, so I might need to open up this window. I want to see where this happens. So there's negative 1, and I'm going to try to figure out where this equals it. So I'm going to go back to a standard viewing window. Zoom 6. Okay, so it happens a bunch of times, but we only care about the interval from this back to 0 to 2. So this guy right there, second trace intersect. Okay, right there, enter, enter, enter. So it is happening at an x coordinate of 1.016. Okay. So that's where the place is on my graph. So if I go back to my original function, get rid of that, oops, and get rid of that. It's happening at this x coordinate. So if I want to write the equation of the tangent line, I have my slope equals negative 1. And I have my point, x equals that, while y equals, and I would have to plug that back in to my original function. So for that, I can just check my table, because I have my original function right there. So I can check second trace value, and I can look for the value at 1.0161378, and that's going to give me my y coordinate, 1.7999. And I'm just copying this down, 1.7999726. So point, slope, write the equation of the line. So y minus 1.7999726 equals mx minus 1.016137.8. So when I distribute my -1, negative x plus 1.016137.8, and add my 1.7999726 over, I get a tangent line of negative x, and then I need 1.016137.8 plus 1.7999726. 2.81611104. Okay, moment of truth. So there was my original, there was my average rate of change, and then I'm secant line rather. Original, secant, and negative x plus 2.81611104. And my window is from 0 to 2. And I'll go from -1 to 3, I think is what we did, so we could really. So here's my original function that we already saw. Here is my average rate of change, and hopefully I find a parallel line that just nicks the curve. Perfect. So definitely long, a lot to keep track of, like, wait a minute, what are we doing again? And then, of course, the use of the calculator. No one's going to get that equation, obviously, just taking a look at the answer of that number without it. When you actually take the derivative and set it equal to -1, you kind of realize we have no idea how to do that. So that's 55. Thanks for giving me some mental stim tonight. 47 asks for, I'll just throw the book under here. 47 asks you to determine whether or not mean value theorem can be applied on the closed interval, and if it can, find all the values where the function has the same slope as the average rate of change from 0 to pi. The thing with tangent is that it's undefined at pi over 2. So 47 is not continuous along that interval, so it jumps, and therefore this whole mean value theorem is thrown out the window without that continuity at pi over 2. So 47 we would throw out and say it's not continuous at pi over 2. 49, a log one, I'm going to copy that one down because that one is continuous. The only place where it wouldn't be would be if x was 0 or a negative number, but that we don't have that issue. So I'm going to go ahead and do this one and copy it down. 40, here I am. Getting so into my work, you guys, that I'm breaking my pencil, and I'm almost out of lead. Okay. F of x equals x log base 2 of x, and we're talking about the interval from 1 to 2. So we know it's continuous from 1 to 2. We want to find the average rate of change from 1 to 2. So 1 comma something and 2 comma something. So 1 times log base 2 of 1. 2 to what power gives you 1? It's 2 to the 0 that gives you 1. So this is 0. 0 times 1 is 0. And then when I plug in 2, 2 times log base 2 of 2. 2 to what power gives you 2? That's 1. 2 times 1 is 2. So my average rate of change on this interval for this function, y2 minus y1, x2 minus x1, is 2 over 1 is 2. So the average rate of change is 2. So we're going to find out at what locations this actually has a slope of 2. And the derivative of this is going to require the product rule. So first times the derivative of a log, I'm going to go jump to my cheat sheet here, derivative of a log, 1 over the natural log of the base 2 times x. So first times derivative of the second plus second times derivative of the first, which is 1. Now this x and this x cancel. So we're trying to solve 2 equals 1 over ln of 2 plus log base 2 of x. So again, I'm not feeling like we can solve this. I mean, we can subtract this over, so 2 minus 1 over ln of 2 is just a number. And then we would do 2 to this power is your answer. So 2 to the 2 minus 1 over ln of 2 equals x. Base 2 raised to the other side equals x. So that is x, but we obviously don't know what location that is, but I can type it in. 2 to the 2 minus 1 over the natural log of 2. .47. Bear with me for a second. Oops. So that's what I got. This is what their answer is, 4 over e. I think I know how they're doing that, but they're obviously the same decimal, so that's your answer. That's the location. I think they're using exponents rules here, so they're doing 2 to the second over 2 to the 1 over ln of 2. And so they're getting 4 over, and that's just 2 to the 1 over ln of 2 is just e. I think that would just take me a while to wrap my head around that and to iron out 2 to the 1 over ln of 2. But same answer. What I got and what they got are the same. This is 4 over e. So trickier, but not terrible. And then 51, which says f of x equals x over x plus 1, and they're giving us an interval -1/2 to 2, and they're saying this. A, graph the function. This is just like the other 155 that we did. So we're going to graph the function first, clear out all this other good stuff. X over x plus 1 in parentheses. Interval window -0.5 to 2. Take a look at my table. -0.5 to 2. That's really in the 0 to 1 range. I'm going to go -1 to 1. So make sure I have it all. Okay, so -1/2 to 2. We see the whole thing. So the average rate of change, -1/2 comma something, 2 comma something. I'm going to cheat and use my calculator. So second trace value, -0.5 is going to give me a y coordinate of -1. And second trace value, x coordinate of 2 is going to give me a y coordinate of 2/3. So my slope is y2 minus y1 over x2 minus x1. So that's -3/3 minus 2/3 is -5/3. And -1/2 minus 4/2 is -5/2. So if I keep, change, flip, keep, change, flip, 5/2 becomes 2/5, 5, 5. It'll be 2/3 is my slope. So point, I'll use this one, slope. So my secant line, sorry, just dropped my calculator, y minus y1, so y plus 1 equals 2/3 x plus 1/2. Distribute 2/3 x plus 1/3, and then subtract over your 1. So y equals 2/3 x minus 2/3. When I add that to my graph, hopefully we'll see that that's an accurate secant line. 2/3 x minus 2/3. Okay, so my average rate of change is right there. So at some point on the graph, if I were sliding this like a pencil, my guesstimate is that it's going to be right around there. Wherever the derivative of my curve equals 2/3, that's my answer. So I want to take this, go down, derivative needs to equal 2/3, and that derivative is going to be a quotient rule. So bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. So x plus 1 minus x is just going to be 1 over x plus 1 squared. Cross multiply. Divide by, let me just make sure this looks a little funky. I want to make sure I'm doing this right. It's going to be x plus 1 minus x, which is just 1. Okay. So cross multiply, then x plus 1 squared equals 3, square root of both sides, so x plus 1 equals plus or minus root 3, x equals negative 1 plus or minus root 3, so it's actually going to happen twice. So one has an x coordinate of negative 1 plus root 3, comma something, and the other one has an x coordinate of negative 1 minus root 3, comma something. So again, on my original function, I'm going to deselect my secant for a second. But on my original function, I'm going to find my y coordinate in a faster way. Second trace value, negative 1 plus root 3 is going to give me a y coordinate of 0.4226. 4226. 4973. So point with a slope of 2/3 should give me one equation, and then point here, second trace value, negative 1 minus root 3. Oops. And negative 1 minus root 3 is, let's see, off the interval, so that negative 1 minus root 3 is at negative 2.7, and remember, we're only looking for the interval from negative 1/2 to 2. So negative 2.7, although this function does have a slope of 2/3 at that point, we aren't going to look at it because it's not in the interval that this mean value theorem is looking at. So this is our point, and our slope is 2/3. So y minus 0.42264973 equals m x minus parentheses negative 1 plus root 3. And rather than go bananas and simplify all that out, I'm just going to go ahead and type it into the calculator. We can bring back our secant. But watch how I type it in. I'm going to do just that, and then I'm just going to do plus that big decimal at the end. So 2/3, oops, 2/3 parenthesis x minus, open another set of parentheses because you're subtracting this binomial x coordinate, negative 1 plus root 3. Close that first one, close the second one, and then add over the 0.42264973. And say a little prayer that this tangent line that's about to come up right now, oh no. Uh-oh. Where did I go wrong? So my secant line definitely had a slope of 2/3, so we know that that's right. Let's go back. We take our derivative, bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. this is x plus 1 minus x, which is just 1 over that, has to equal 2/3. And, oh, it's 3/2. I had to divide the 2 over. Shoot. So the square root of 3/2 plus or minus the square root of 3/2 plus or minus the square root of 3/2. Let's go back and just change it. It's just 3/2. Ay, caramba. 3, second insert, halves. Oh, it's not under my thing now. Hold on. Oh, there we go. 3/2. Did that fix it? Wait, was my 4226 thing found? It was. That's the wrong number now, too. Delete. Delete. I had to go back and find that number. Hold on. Turn that off. Turn the secant off. Go back up to just that. Second trace. I want to find the y coordinate when the x is -1 plus the square root of 3/2. Enter. 0.18. 350,342. Okay, moment of truth. So that's the 0.18350,342. Okay, sorry. Brainstorming. Lord help us if this doesn't fix it. 2/3. Got that. Plus 0.18350,342. Secant. Please, 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 please. Oh, nailed it. Okay. See, just one little mistake, you guys. This is college math at its finest, when you were thinking too quickly, you never divided your 2 over, you lost your 3/2, throws off the whole problem. But it's a quick fix. We got it. Sorry about the hiccup. And I can't blame you for not telling me when I screwed up, because I feel like in the classroom you would say, wait, you forgot the 3/2, and that would have saved me that headache. But we're good. Long video. Maybe if you text me a thumbs up. First 5 people that text me a thumbs up get a bonus point. Love it. See who stuck with me. All right. Have fun. See you later. Don't tell anybody. If you're going to text me a thumbs up, don't tell anybody. Keep it honest.